Hi, it's Mrs. Murat here with help on the Unit 3, Lesson 19 practice problems. On number 1, it says without calculating solutions, determine whether each equation has real solutions or not. Well, I noticed that there's some graphs given here and that each of these equations correspond to one of the graphs. So this graph, y equals negative 0.5x squared plus 3x, that's going to help me solve A and also D. Okay, so I'll use that graph there. So for A, equal to 0. Well, this is equal to 0 in two real places. So this is real. And then for D, equal to 3. Well, here's 3. And it's also two places there. So those are also real. All right, the next graph is y equals x squared minus 4x plus 7. And I'm going to use that graph to answer questions B and E. So for B, when is it equal to 0? Well, it doesn't touch the x-axis, so these are not real. And then for E, equal to 5, here's 5, and it crosses the function in two places. Those are real solutions. And then the last graph, y equals 2x squared minus 2x minus 1, is going to help us with C and F. So for C, the function is equal to 0, again, in two real places, so real. And then the function does not come down to negative 4, so those solutions are not real. Okay, moving on to number 2. The graph shows the equation of, let me zoom in here a little bit. Okay, so the graph shows the equation of y equals 2x squared plus 0.5x minus 4. Based on the graph, what number could you put in the box to create an equation that has no real solutions? So if it's going to have no real solutions, and I can see here that the graph, the bottom of the graph is here at negative 2, then any number below negative 2 is a number I could put into the box so that the equation has no real solution. So I'm going to say negative 4. But you could have said negative 3 or negative 5 or negative 8, anything that's less than negative 2. All right, number 3. Here's the graph of y equals 1.5x squared minus 3x plus 2. Without calculating the solutions, determine whether 1.5x squared minus 3x plus 2 equals 0 has real solutions. Well, I can see on the graph, it doesn't come down to the x-axis where it would equal 0. And so by the graph, I can see it does not have real solutions, but I could also calculate the discriminant, b squared minus 4ac. Negative 3 squared is 9 minus 4 times a times c. And so when I find that value, nine minus 4 times 1.5 times 2, I get negative 3. So I can see that there are no real solutions. Again, they're going to be complex solutions because the discriminant is a negative value. And then if I'm going to actually solve it, I'll use the quadratic formula. And then the nice thing is I've already calculated the discriminant. So looking back at the equation, I can see A is 1.5, B is negative 3, and C is 2. And I can go ahead and define those values because we have a 0 over here. So if this was any other number, I'd have to add or subtract to make it a 0 first. All right, so x equals negative b. So Negative negative 3 is 3, plus or minus. I already calculated the discriminant. It's negative 3. We did it right here. And then the whole thing over 2a, 2 times 1.5. And that's going to equal 3 plus or minus I root 3 over 2 times 1.5 is 3. So then the last step is to break it apart, dividing each of the terms on the top by the 3 on the bottom. So 3 divided by 3 is equal to 1. And then I'm just going to leave that as I root 3 divided by 3. And that's the final answer. Okay, on number 4, so this answer, you could have lots of different answers for number 4. You just want a quadratic where it's not going to ever equal whatever number you put there. So what I mean by that is you could have a quadratic in factored form like x plus 7 squared, like that, and then have it equal to a negative number, negative 25, let's say. That's going to have non-real solutions because when I square root, I'm going to have a negative number under the square root. So that's an example of how you could figure that out. Or you could just make up a quadratic and look at it on a graph and then determine what value you want to set it equal to so it does not have real solutions. So an example of that might be this one here that I have on my screen. Okay, so the equation that I wrote for this one is 2x squared plus 3x plus 5. Okay, so that's the function that I have graphed here. And then I can see that its vertex is around 4 here. So maybe I would just say, oh, equals 2. So see if I graph y equals 2, then they're not going to touch on this real plane, the red parabola and the blue graph. They're not going to touch on this real plane. You can see that really clearly now. And so instead of having real solutions, this would have complex solutions. So there's 2 examples of how you could answer number 4. Okay, on number 5, I'm going to use the quadratic formula for each of these. And just keeping in mind that in order to use the quadratic formula and to determine the values for A, B, and C, the equation has to be equal to 0 first. So to do that here, I have to subtract the 2.5. So negative 2x squared plus 2x minus 2.5 equals 0. Okay, and then the formula x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, and so I'll use my calculator, find the number under the square root called the discriminant. 4 minus 4 times negative 2 times negative 2.5 is equal to negative 16. So I have x equals negative 2 plus or minus the square root of negative 16 over negative 4. Okay, and then finally, I'm going to divide both sides by negative 4. So negative 2 divided by negative 4 is 1/2. and then plus or minus, this is 4i over -4. So here's the interesting thing, is that I'm going to put my -4 here, but see how now I can simplify it a little bit further. And then also the plus or minus in the middle, I'm actually going to write this as 1/2 plus or minus I, because 4 divided by -4 is -1. And I don't have to really worry about the sign because I have plus and minus. And so it kind of just works its way out. So this is the final answer for A. B is lovely. I'm going to go ahead and change that to a 0.5 to keep it consistent with the 4.5 at the beginning. And it's already set equal to 0, so I can go ahead and set up the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac over 2a. Okay, so this is -3 plus or minus, I'll figure out that number in a minute, and then 2 times 4.5 is 9. All right, so the number under the square root, the discriminant, 9 minus 4 times 4.5 times 0.5 is actually equal to 0. So I'm adding and subtracting the square root of 0, which is simply 0. So the final answer here is just -3/9 or -1/3 once we reduce it. Okay, for problem C, I'm going to do two different things. I'm going to use 0.5 for the x for the a value, and I'm also going to add the 14 so that the equation is equal to 0 before using the quadratic formula. So I just think it's easier to have a decimal in the formula. That's why I'm changing that to 0.5. And then plus 5x plus 14 equals 0. So x equals -b plus or minus the square root of b squared minus 4 times a times c. All over 2a, 2 times 0.5. Okay? So that's equal to -5 plus or minus. This equals -3. 25 minus 4 times 0.5 times 14 is equal to -3 altogether. And then 2 times 0.5 is equal to 1. And so I'm just like dividing by 1. So my final answer here is x equals -5 plus or minus I root 3. Okay, the I comes out because of the -3, but the 3 stays under because it's not a perfect square. And then finally, problem D. It's currently equal to 7. I need to change that by subtracting the 7. So -x squared, so a is -1, minus 1.5x, so b is -1.5, and then minus 2, so c is -2, equals 0. All right, so here we go. X equals -b, so positive 1.5, plus or minus the square root. -1.5 squared is 2.25, minus 4 times a, which is -1, times c, which is -2, all over 2 times -1. So that means x is equal to 1.5 plus or minus, I'm not sure of that yet. 2 times -1 is -2. All right, so 2.25 minus 4 times -1 times -2 is -5.75. Now, 5.75 is not a perfect square, but I am going to bring out the square root of -1, and then I'm also going to distribute the dividing by -2. So on the answer key, you'll see 1.5 divided by -2 is equal to -3/4 if you simplify it as a fraction. And then we have plus or minus I root 5.75. And then that's just going to be over 2. So even though this is a -2, because it's plus or minus, it kind of takes care of whether or not that's positive or negative. If you kept your -2 here, it's actually the same solution. It's kind of interesting to think about. It's because of the plus or minus in the middle. All right, so this is the final answer. I'm pretty sure the answer key, though, has the I, like after this is a fraction. They mean the same thing, so either representation is totally fine. All right, we've just got one more quick problem here. And I actually figured this out using my calculator, because when I look at the two possible solutions, so here they solved this equation. They must have used different methods and got different answers. The only part of their answers, Elena and Kyron, the only part of their answers that are different are the square root of 0.5 versus the square root of 8/4. So I'm going to use my calculator to say, well, this is about, and same with this. I mean, there's other ways we could figure this out, but we haven't really focused on simplifying radicals so much this year. So I think this is probably will show us, gosh, I'm trying to get it out of the glare, will show us kind of, what we need to know. So the square root of 0.5, see how that's that long decimal? Well, if we do the square root of 8, and then remember when you divide by the 4, it's outside of the square root, so you have to arrow over to the right, and then divide by 4. Look at that. They are the same. So using a calculator, you can see that their solutions are equivalent, okay? So they're both about 0.707, and they're exactly the same decimal the whole way. So they are equivalent. All right, so that is the end of the assignment. I hope you found this video helpful. As always, though, if you still have questions, then you need to ask your teacher when you're back in class together.